This example says the rose curve R equals sine 4 theta has 8 petals. Find the area of one petal. Okay, so part of the setup here is really easy. We're just going to take the formula that we have up here for area, and we're going to say the area here is integral, well, it's 1/2 integral of sine 4 theta squared d theta. And of course I can rewrite that putting the square on the inside if I want to. The tricky part here is figuring out what are those endpoints. So we've got to find the endpoints of one petal. So there are a couple of ways we could do this. I want to do it, I want to look at it on Desmos, and I want to work it out manually. All right, so sine 4 theta, I've already got it written, drawn in here. When b, if I move this around, we want to figure out what is the starting theta and the ending theta for this first petal. Well, the starting theta is 0. The ending theta is like 0.75, like 0.75 radians. But we can't just estimate that. Let's look at where this comes from. All right, if I just were to graph y equals sine 4 theta, actually, I'll just do that on Desmos too. If I graph y equals sine 4 theta, or sine 4x, we want to figure out where does this touch the axis here? So this section here going from 0 to pi over 4, that's when the radius goes from 0, extends up to being 1, and then drops back down to 0. So that's at pi over 4. If I draw this in on the same stuff, right here at 0, that's going to be right here at the origin. And then if I can trace along this, I don't know if it'll let me. It won't. But if I take this, and instead of going to pi over 2, if I go to pi over 4, that gets me that full lobe. If I just subtract off a little bit, it doesn't get quite there. So 0 to pi over 4 is what we want. Now I want to get the exact answer to this. So let's actually work this integral out. This is going to be one half of integral from 0 to pi over 4 sine squared of 4 theta d theta. So how do we deal with the sine squared? Well, we need our formula sheet. Or if you've used the formula enough, you'll remember it. Sine squared is 1/2 1 minus cosine. The formula says 2 theta, but it's really double whatever the original one was, so this is going to be cosine 8 theta. It's still from 0 to pi over 4. All right, so what do we got there? We got a 1/4 on the front, and we can integrate that right off the bat. Integrate 1, you get theta. Integrate cosine, you get, excuse me, you get, integrate cosine, you get sine. The sign doesn't change, but we have to divide by 8. Then we're going from 0 to pi over 4. So let's plug our numbers in. You get pi over 4 minus 1/8 sine 8 times pi over 4. And then we don't have to plug the 0 in, because if you plug the 0 in, this is going to be 0, and this is going to be sine of 0, which is 0. So we get this, so that's going to be 1/4 times, let's see, pi over 4 minus, this is sine of pi over 2, or no, it's sine of 2 pi. So this whole thing is just 0. So this just gives me pi over 16. All right, let's double check our answer. Over here on Desmos, I'm going to put in integral from 0 to pi over 4 of sine 4 pi, 4 theta squared d theta. And let's see, I also need to put a 1/2 on the front of that. So that gives me 0.1963. Let's compare that to pi over 16. When I do that on my calculator, I get 0.1963. So yeah, we're good. The trickiest part of this is really finding the beginning and ending of one lobe of this, but it's really not that bad. The easiest way to do it, I think, is to just look at a graph of, in this case, y equals sine 4 theta, and then figure out the start and end of a petal.